Have you ever looked at a pile of garbage and wondered where it goes after the trash truck disappears down the street? For most of us, waste is something we think about for a split second before tossing it away. Out of sight, out of mind, till it comes back to haunt us in the form of polluted rivers, choking air, or mountains of landfill that never seem to shrink. The truth is, the story of our waste doesn't end at the bin. In fact, it's only just beginning behind the scenes, far from the eyes of everyday life. An extraordinary network of industrial giants is working day and night to tackle one of humanity's biggest and dirtiest problems, waste management. And in the United States, these facilities are among the most advanced in the world, combining massive scale with cutting-edge technology to keep our environment from collapsing under the weight of our own consumption. Today, we're stepping through the gates of these giants' facilities so large and powerful they can swallow entire truckloads of garbage and transform them into electricity, clean water, or even fuel. We'll journey through the blazing heat of wasted energy incinerators, the silent but crucial precision of wastewater treatment plants, and the almost sci-fi world of plastic pyrolysis reactors. We'll see how trash becomes power, how filthy water is reborn clean enough to return to rivers, and how stubborn plastics are cracked apart and turned into valuable resources. This isn't just a story about machines and chemistry. It's about our battle for survival in an age of industrial excess. Our journey begins where most trash ends up, at a waste-to-energy incineration plant. From the outside, it may look like a sprawling steel fortress, but inside it's a fiery heart beating with the relentless rhythm of massive turbines and roaring flames. Garbage trucks roll in one after another, unloading mountains of waste from homes, businesses, and factories. Here, nothing is random. Every bag, every scrap is part of a carefully engineered process. Before anything can be burned, the waste is sorted. Metals are pulled away by powerful magnets. Plastics and paper are separated for recycling, and hazardous materials are removed to ensure safety. This meticulous sorting is not just about efficiency. It's about preventing toxic releases and maximizing the energy that can be harvested from what remains. Once sorted, the waste is fed into enormous high-efficiency incinerators. Inside, the temperature soars above 1000 degrees Celsius, hot enough to obliterate most organic materials in seconds. Imagine the crackle and roar as tons of trash are reduced to ash, heat, and gas. But this heat doesn't just vanish into the air. Instead, it's harnessed. Water pipes run alongside the inferno, capturing the heat and turning it into steam. That steam drives massive turbines, which in turn generate electricity enough to power thousands of homes. The ash left behind is much smaller in volume than the original waste and is often treated further to remove metals for recycling or stabilized for safe disposal. What once was a smelly heap of garbage now exists as light in someone's living room. But solid waste is only part of the problem. Across cities and towns, another kind of waste flows silently under our feet: wastewater. Every flush, every sink drain, every industrial pipe eventually leads to massive treatment plants. Here, the battle is against pollutants invisible to the naked eye: oils, chemicals, bacteria, and microplastics. At a large wastewater treatment plant in the US, the process starts with pre-treatment. Screens and grates catch large debris, everything from plastic wrappers to stray branches. Removing these prevents damage to delicate pumps and systems. Further down the line, next comes primary treatment. Wastewater is directed into vast settling tanks where gravity does its quiet work. Heavy particles, oils, and greases drift downward, forming a thick sludge at the bottom. About 60% of suspended solids are removed here, but the water is still far from clean. In secondary treatment, science comes alive in tanks teeming with microscopic bacteria and microorganisms that feed on the dissolved organic matter. It's a living process, one that turns harmful contaminants into harmless byproducts. When the microbes have done their work, the water flows into another set of settling tanks, leaving behind more sludge. For many facilities, the process doesn't stop here. Tertiary treatment is the final polish, where water undergoes fine filtration, chemical treatments, or ultraviolet disinfection to remove the last traces of nutrients and pathogens. Only then does the water meet the strict standards set by the US Environmental Protection Agency and flow back into rivers, lakes, or oceans. The transformation is astonishing. What began as murky, foul-smelling wastewater emerges clear and safe enough for the environment. If incinerators are the fire, and wastewater plants are the cleansing rivers, then plastic pyrolysis plants are the alchemists of the waste world. Plastic waste, one of the most stubborn pollutants on Earth, resists natural decay for hundreds of years. But inside these high-tech facilities, plastics are broken down into valuable fuels and chemicals through a process called pyrolysis. It begins with careful sorting. Only certain plastics are suitable for pyrolysis, so metals, glass, and other contaminants are removed. The plastics are shredded into small flakes to increase their surface area, making the process more efficient. Then, they're fed into a pyrolysis reactor, a sealed chamber, where temperatures climb to between 350 and 700 degrees Celsius in an oxygen-free environment. Without oxygen, the plastic doesn't burn. Instead, its long polymer chains break apart in a chemical reaction called depolymerization.